Hi guys. So today we're going to look at how to solve absolute value inequalities. So the process we use is going to be very similar to what we did for equations, just a couple extra things since we're looking at an inequality. So to start, we're going to start by looking at the graph so we can understand what's actually happening here visually. So if I'm going to solve this inequality by graphing, this is saying when is the function, the absolute value of x minus 2 minus 1, greater than the line y equals 2. So when is it above the line y equals 2? So I'm going to go ahead and start by graphing that absolute value function. That function would have a vertex of 2, negative 1. Slope is 1. So that would be my absolute value graph. And then again, I want to know when it's above the line y equals 2. Well, I'm going to graph the line y equals 2. And then I see it. So I want to know when the purple line is above it. Well, the purple line is above it in that region and in that region. So everything until that point and that point. So if I want to list those values in interval notation, well, in interval notation from left to right, that would be from negative infinity until the x value of negative 1. Then it would be from the x value of 5 to infinity. If I want to write this in inequality notation, well, then I would say that x is less than or equal to, just not or equal to, just less than. X is less than negative 1, or x is greater than 5. It could be either of those two places. All right, so let's look at the next one. Same thing, I'm going to graph this function here. So that's going to have a vertex of negative 1, 2. Slope is 1. And then I want to know when that function is less than y equals 3. So there's the line y equals 3. So the red line is below the yellow line in this region right here. So that's happening from this x value until that x value. So in interval notation, from negative 2 until the x value of 0. So that's where it's below. If I want to write this in inequality notation, well, my x, this would be a compound inequality because x is less than 1, but x is also greater than negative 2. X is falling in between those two values. I'm sorry, that should be a 0, not a 1. And that's where that's happening. So what I want you guys to see about this is two things. One, again, just talking about what this means on the graph, because when we look at negatives, this will kind of help us a little bit. But also, notice the difference in these two solutions. On the first one, I had one inequality or another inequality, and then I had a union in two different intervals when I wrote interval notation. Whereas on the second one, I had one compound inequality and then just one interval. So the difference between these two equations, if you notice, was my less than and greater than symbol. So depending on what that symbol is how we're going to set up these equations to solve them algebraically. So there's two different ways that you could work this out or teach this. We're going to follow very similar to what we did with equations, where we're just going to change what's in the absolute value. But let me go ahead and flip to the next slide and show you another way this is written. All right, so what we like to say, if we're dealing with absolute value of x, we always get it by itself, just like we did with equations. We're going to set up two inequalities just like we did with the equations. The only difference is how we're going to relate those to our solution. So if we have an absolute value that's greater than some value, then we're going to have basically two inequalities and it's going to be one or the other. If I have an absolute value that is less than a, then I'm going to do that inequality is less than a and the other inequality. Okay, so it's going to be an or with my inequalities if it's greater, it's going to be and if it's less than. And kind of the way I like to remember it, it's greater and it's less than. I forgot my T, but it's easier when you say it. So greater and less than. All right, so let's follow these steps to actually solve this equation. So again, the first step, just like it was for solving equations, is going to give you to get the absolute value by itself. So first thing I'm going to do is I'm going to add 7. Then at this point, I still need to get my absolute value isolated, which means I need to divide by 3. And now the absolute value is by itself. Once absolute value is by itself, I can then split this into two equations. So two inequalities. One inequality, just like it was for equations, drop the absolute value bars. The other inequality, just like equations, take whatever's in the absolute value and change the signs. So now I just need to solve these two inequalities. Well, this one becomes x is greater than or equal to 1. And this one becomes negative x is greater than or equal to 3. But remember, we don't want negative x, we want x. Whenever I divide by a negative, I flip the sign. So this becomes x is less than or equal to negative 3. Well, now when I write my solution, what I'm going to do is I'm going to graph the solution on a number line. But I want to consider what I was talking about here with the and the or. So the original problem here, once the absolute value was isolated, was absolute value is greater than a number. So instead of talking about absolute value is greater, this is going to be an or situation. So my solution is either going to be when x is greater than or equal to 1 or when x is less than or equal to 3. So when I graph this on the number line, what that means, here's 1 and here's negative 3. I'm going to graph these two inequalities. X is greater than or equal to 1 would be a filled-in circle and everything going this way. X is less than or equal to 3 would be a filled-in circle and everything going this way. The reason it matters that it's or is because if this was and, it would have to be where both of these things are happening, and both of those things are never happening. So this is an or situation, so we're going to list where either of those two things is happening. So one of these would be from negative infinity to negative 3 with a bracket because it's or equal to. And the other one would be from 1 to infinity, also with a bracket. And that's how I'd write my solution in interval notation. All right, let's go ahead and look at this next one. So what I'm going to do is get the absolute value by itself. And I'm going to divide by negative 2. Remember, when you divide by a negative, you flip the sign. Now I'm going to separate this into two inequalities. So one of them, I keep the signs the same. I don't change anything. On the other one, I change the signs of what's inside the absolute value. And then I'm going to solve both of these inequalities. Well, that leaves me with x is less than or equal to negative 2. And that leaves me with negative x is less than or equal to 4. So x is less than or, flip the sign. X is greater than or equal to negative 4. Sorry guys, lost some internet. So x is greater than or equal to negative 4. All right, so again, we're dealing with an absolute value less than so this is going to be an and situation. I need to know where both of these things are true. So we're going to graph this on our number line. So x is less than or equal to negative 2. So here's negative 2. Less than or equal to would be everything going this way. Then we're going to graph negative 4 on my number line. Greater than or equal to is everything going this way. Since it's and, my solution is going to be the overlap of those two things. Well, the overlap of those two things is from negative 4 to negative 2. Since it's or equal to, we're going to use brackets. All right, let's look at a couple more examples. So again, first step is to get the absolute value by itself. So absolute value of 2x plus 1 is less than negative 5. Now, the previous examples, we said those were the rules when it was absolute value and it was compared to a positive number. It's very different once we're comparing it to a negative number. Because what happens with that negative number, let's think about this graphically. It's saying when is the absolute value function, which is something like this, when will that function be less than the line y equals -5? Well, that's never going to happen. Okay, think about it algebraically. Absolute value is always going to give us a positive number. Will a positive number be less than a negative number? And that's never going to happen. So then this graph, or this inequality, is going to have no solution. All right, let's look at the next one. Same concept. Get the absolute value by itself first. Now we're looking at very similar, except this time it's greater than a negative. Well, again, we just looked at the graph. That graph is always above that negative line. Algebraically, a positive will always be greater than a negative. So in this case, it's all real numbers. And then if we're writing that in interval notation, -infinity to infinity. Now, we cannot make these decisions until the absolute value is by itself. Don't just say, oh, look, there's a negative here, so it has to be all real numbers. You have to get that absolute value by itself first, because if this was a -4 instead, it no longer would be a negative on the other side, and we could actually find our solution. So that means if we're dealing with absolute value that's isolated, less than a negative, well, that is never going to happen. That has no solutions. But if we're doing absolute value greater than a negative, that is always going to happen because positives will always be greater than negatives. All right, E and F are actually two special cases. So let's look at E and F. Again, get absolute value by itself. And I'm looking where it's greater than 0. Well, again, think about what this graph is going to look like. X minus 4, it looks like it's always greater than 0. The only thing here that's tricky is at this one exact place, it's not actually greater than 0. At one place, it's equal to 0. And when it's equal to 0, it's not greater than 0. So the place where it equals 0 is at x equals 4. So since that is not actually a true statement, that is the only value that x cannot be. So in this case, x does not equal 4. If you want to write that in interval notation, -infinity to 4, union 4 to infinity. All right, then let's look at this next one. Again, get absolute value by itself. And the absolute value is still not by itself. Divide or multiply by -1, which flips your sign. So now we're saying, when is the absolute value of x minus 4 less than or equal to 0? Well, it looks like it's everywhere because that absolute value, whoops, I'm sorry, flipped it. It's actually going to look like it is graphing the right one. All right, so it doesn't look like it's anywhere because all of it looks like it's above that axis. However, because this is less than or equal to, there is one place where it does equal 0. So in this case, there is one solution. That one solution is that x equals 4. So those are two special cases. So if you get your absolute value by itself and you're comparing it to 0, you do need to be just careful about what solutions you're actually talking about at that point. All right, so let's go ahead and look at two more examples. Go ahead, if you feel pretty comfortable, pause the video and try these. All right, so again, I'm going to get the absolute value by itself. So I'm going to subtract 3. Divide by -2, which is going to flip my sign. So what that does now is I set up two inequalities. X minus 3 is greater than 4. Since it's greater, it's an OR equation. Change the signs and solve both. So -x is greater than 1. X is less than -1. Solve this equation over here. X is greater than 7. And then let's plot it on our number line. There's -1 and there's 7. X is greater than 7. X is less than -1. Since it's OR, we're looking for where either of those things are true. So -infinity to -1, and then from 7 to infinity. All right, looking at H. Okay, get the absolute value by itself, so I'm going to multiply by 3 over 2. And now this is less than, so I'm going to set up two inequalities with an and. So 3x minus 2 is less than 6, and negative 3x plus 2 is greater than 6. So that leaves me with 3x is less than 8. So x is less than 8 over 3, and negative 3x is greater than 4. X is less than negative 4/3. And I realize I flipped my sign on the original there. Hang on. Sorry about that. That was negative 3x plus 2 is less than 6. So negative 3x is less than 4. So x is greater than negative 4/3. All right, plot them on a number line. So x is greater than 4/3 is this region. X is less than 8 over 3 would be this interval. Since it's and, the intersection would be in between here. So negative 4/3 to 8/3. Since it's not or equal to, we are using parentheses. All right, we're going to do 2 more. This time we're going to look at them in comparison to another function. All right, so again, set this up. The absolute value is already isolated. So I would do 2x minus 3 is less than x plus 1. That's one of my equations. It's less than, so I would then do negative 2x plus 3 is less than x plus 1. So then solve these inequalities. That would give me x is less than 4 over here. And then over here, negative 3x is less than negative 2. So x is greater than 2/3. Plotted on our number line. X is less than 4. X is greater than 2/3. And is the overlap. So from 2/3 to 4 would be my interval of my possible solutions. All right, then let's look at J. So on J, we have absolute value compared to an absolute value. So what I can do here, there's 2 ways you can work this out. So let's look at this graphically. So this equation over here, this would have an x-intercept, this would have a vertex of 2, 0. It's going to open down because it's negative. Then I have this equation over here, 2x minus 8. Well, that's also going to be stretched. It's going to be shifted to the right 4. It's going to look something like that. So this question is saying, when is the purple graph above the blue graph? Well, that doesn't happen. So this has no solution. If you want to look at this algebraically, okay, what I would have here, I would have negative 2 times an absolute value. Well, negative 2 times an absolute value is going to be some negative number because the absolute value is always going to give us a positive. Well, over here on the right side, that absolute value is going to give us a positive. So what that tells me is that I'm going to have some negative number that's greater than some positive number. A negative is never going to be greater than a positive. So again, that tells us that there's no solution. All right, so the last thing that we're going to look at is we are just going to look at some word problems. So it tells us in this first one, a machine cuts boards that are 3.25 meters long. They're not cut perfectly each time, so the company sets an allowable amount of error of 0.02 meters. So if the board length differs by more or less, it's thrown out. So we're going to write an inequality that shows us the acceptable range of lengths. So what we know is that the error has to be less than or equal to 0.02 meters. Well, the way that we determine the error is we take the length of the board, we subtract 3.25, and then we do the absolute value. Because if it's greater than that, well, it's just going to be the number. But if it's less than the 3.25, it would give us a negative, but absolute value would then just tell us the total difference that's between it. So then if I want to solve this inequality, x minus 3.25 is less than or equal to 0.02. So x is less than or equal to 3.27. My other equation, less than, so it's and. Negative x plus 3.25 is less than or equal to 0.02. So negative x is less than or equal to negative 3.23. So x is greater than or equal to 3.23. Since it's and, I'm looking for the overlap, which is from 3.23 to 3.27. Now, when you're writing these inequalities, again, keep in mind, typically the setup here that we're going to have, that's basically our midpoint, and that's your differential. All right, so let's look at this last one. The weight of a healthy newborn baby can range from 5.5 pounds to 7 pounds, or to 10 pounds. So we're going to write an inequality that shows the possible weight. So we already know the solutions here. We're just trying to write the inequality that shows all the possibilities in between. So what we could have here, basically, like we said, we're going to take x minus the midpoint, and we want that to be less than or equal to the differential. So our midpoint here, halfway between 5.5 and 10, would be, oops, sorry about that, hit the wrong button, would be 7.75. Then the differential there, how much it's varying from that midpoint, would be 2.25. So if you solve that algebraically, then you would get x is less than or equal to 10. You would also get that x is greater than or equal to 5.5. All right, so that's it for absolute value inequalities, and we will continue looking at quadratics after this.